Hello, and welcome to a special episode of the Daily Space. It's not so special except for the fact that we have a whole lot of news, but I'm not the best person to listen to about it. Last night, the New Horizons team, working with the media office at Johns Hopkins University's Advanced Physics Laboratory, put together an amazing show. They managed to get their hands on the connections to NASA TV during this government shutdown. And without NASA TV there to handle the production, they did it on their own. And what they did was something like I've never seen before. They had on their colleagues from the OSIRIS-REx mission, which entered orbit around Bennu yesterday. They had colleagues from future missions like Psyche that are just in the early planning stages. They talked about the science of Bennu. They talked about the science they hope to do at Ultima Thule. They brought on their friends, they sang songs, they celebrated. It was a new year, and it gave us a new idea of just what science communications can look like when people, communicate with passion from the heart. So I'm going to encourage all of you to go watch last night's many-hour stream that came out of the New Horizons team. We do have it as video on demand here on CosmoQuest X, where Annie streamed it out with her dogs and with a bunch of you, so you can see what people were talking about in the moment. Now, today, we are just recovering from, getting up early to see if New Horizons signal made it back safely to Earth after their encounter with MU-69 Ultimate Thule. The answer is yes. Yes, they did. At roughly 10:15 this morning, they sent back signal that all was right with the world. And this meant that they'd safely went past the object. They filled their hard drives up with data that is going to very slowly get beamed back to Earth. And telemetry looks good. They are moving on into the future. Now, we are hoping tomorrow that we will get some of the early images down that were some of the last images taken right before the flyby started. And it's going to take 2 months before we can get the best of the flyby images in hand. Now, let me see what I can do to pull up for you some of the images that have been taken. This will take me just a moment. While I'm doing this, I wanted to give you a thank you so much for the follow. I wanted to give you a quick update on what's going on with CosmoQuest. We are in the process of moving everything over to a new software platform, new designs, and hopefully a improved user experience for all of you. This is going to take us a bit of time, so you're going to notice that we are under a maintenance screen, but hopefully just for a little while. All of us are going to work our butts off until everything is done, and I can't wait for you to see the things that we're creating. But I'm on the wrong keyboard to get things so that you can see them. We're all a little bit sleep deprived as we were up late coding and watching the encounter. And then I got up this morning early to see on the results of the encounter. So let's see what I can get you. So Twitter is going to be my best source, and that makes me a bit sad. But this is life sometimes. So if you have any questions, is there an official sub? What do you mean, String Theory? I'm not quite sure what you mean. So go ahead at me with any questions that you might have in the chat, and I will do what I can to answer things. For those of you who are new, I am Dr. Pamela Gay. I am the principal investigator of CosmoQuest.org. I am also chief cat herder around here, and today I am the host here on CosmoQuest. We are your place to get involved in learning and doing science. And we invite all of you to, well, in general, but not today while we're updating, we invite all of you to join us in exploring our solar system. Now, this is part of why we're doing massive updates. It's to bring you new science projects, new tools, better ways to do things. There we go. It's trying really hard to get me to log in, and I don't want to. Top news. I don't want top news. I want the hashtag. Latest. There we go. So I will share this with you in just a moment. I simply wanted to make sure I had a clean screen first. Thank you so much for the bits. We live and die by the bits over here. Okay, so here we go. This is the highest resolution image we have of Ultima Thule so far. This is an itty-bitty little tiny object or objects estimated to be about 30 miles in total length. Now, what has us confused is no one quite knows exactly what we're looking at. The confusion comes in the fact that this could be two objects or one. And the other thing that's confusing is how they're moving through the sky. Now I keep wanting to rotate my coffee cup, and I think it's finally empty, so I can do this. Okay, so my coffee cup has roughly the same shape as Ultima Thule. Now, if my coffee cup were rotating like this, then the amount of coffee cup that you see at any given moment will be changing. And when you're seeing this much of it, it's a larger surface area, so you would essentially see a brighter point in the sky. But when it is rotated like this, well, you're seeing a whole lot less surface area, so you would be seeing a whole lot less brightness. Now, as we have been observing MU69 Ultima Thule in the approach up to this flyby, we haven't seen it vary in brightness, and this has been greatly confusing to the entire mission team. Well, now we have new information, and I'm hoping that I have a light curve here that I can find for you that will show you what they think is going on. Pardon while I scroll through. Oh man, I'm not seeing anyone captured this. I should have screen captured the videos more. People are likening this shape to so many different things. Okay, let's scroll up to the top. Nope, I'm not going to find anything. Okay, so going back to this. So in looking at things during the most recent imaging round, they were able to catch the object at a variety of different angles, and it appears as it rotates, it's not rotating in any plane that would cause the amount of it that we're looking at to change. Instead, what's going on is it's rotating in the plane of the sky. So while the orientation changes, the total surface area that we see at any given moment stays constant, and thus the total brightness that we receive from the object stays constant. Now, what remains a point of confusion is we don't know for certain, and here I'm going to grab 2 small planets. Whoa, and I'm going to step on a puppy. Didn't mean to step on the puppy. I'm going to grab 2 small planets from off camera. So what we don't know for certain is if this is what we call a bilobate object. This is an object where you essentially have 2 blobs touching one another and gravitationally bound or structurally bound together loosely. Or if this is 2 objects that are orbiting one another very, very closely. The more likely option is that this is what we refer to as a bilobate object. This is simply a shape that we see quite often in the sky, so nothing unusual about that. Now, the idea that it is actually 2 different objects, that's a lot more rare. This partnering of how close they would be seems unlikely, but we will know tomorrow exactly what the situation is. Now, because this object is so very far out in the solar system, that means New Horizons is also really far out in the solar system. Data from the spacecraft is taking roughly 6 hours to make its way all the way back to Earth, complicating things further. The Earth is on the wrong side of the sun compared to this object, so our orbit is adding extra distance. In the coming days, Pluto's actually going to briefly pass behind the sun. Not Pluto. MU-69 and New Horizons are going to briefly pass behind the sun, and we will lose signal. It'll come back, of course, when the object is no longer blocked by the sun. But at this great distance, the problem is that just like you lose Wi-Fi the further you get away from your router, well, it's because the signal drops. With this, we don't lose signal, but we lose signal intensity. And this means that we have to transmit very slowly to get every bit of possible information back. They are estimating that it will be February before we get the highest resolution images that were taken during this flyby. And of course, it will take even longer to get all the data down off the spacecraft. But this is okay. Planetary science is the long game. We're used to having to wait for our information. The spacecraft, after all, did launch all the way back in the summer of 2006 when Pluto was still a planet. It takes a long time to travel through our solar system. It takes a long time for the data to travel through our solar system. And it takes a long time to analyze the data when it gets back to Earth. But eventually we'll get there. So that's what we know at this point. It's not a lot, but it's what we know. Now, the other cool things that are going on right now is, as I said, the OSIRIS-REx mission has gotten itself to Bennu, where it is in orbit around this not so distant, not so very distant asteroid. Let me switch over to showing you video that we have coming to us from the New Horizons team. So this is video that they showed yesterday of OSIRIS-REx on encounter, and let's just get
We have arrived. Preliminary survey is a series of maneuvers about 2 days apart and consists of 5 hyperbolic flybys, so essentially a straight line relative to the asteroid. And we do 3 of those over the northern hemisphere, we do 1 over the equator, and we do 1 under the southern hemisphere. And that allows the scientists an opportunity to collect lots and lots of imaging data that aids in building shape models and also eventually in sample site selection. At the completion of a preliminary survey, which is about 3 weeks, will drift away from the asteroid, come back, and insert into orbit on December 31st.
What's really groundbreaking about the navigation on this mission is the size of Bennu. Bennu is the smallest object to ever be orbited by a spacecraft. The gravity is so low that we can effectively maneuver all around the asteroid with very little fuel cost.
So that is what we currently have coming from the OSIRIS-REx mission. And it is now in orbit. And I see that we have some questions coming in on the chat. Hanny's Vorverp is asking, is New Horizons going to do the same type of heliopause research that the Voyagers have been doing? I don't know. So the thing that we have to remember with New Horizons is they've still got a little bit of fuel. They still have the potential to move their mission around and explore a couple more Kuiper Belt objects, or at least one, should they choose to and should they be allowed to due to funding. At the end of the day, these spacecraft, well, they don't have to stay on. Occasionally, Congress, NASA, the president will decide we're done with this spacecraft and it will get shut down. Currently, the mission is still fully operational. It is still bringing back data, slowly. So if it stays funded, it will hopefully be able to encounter at least one more object, and then we'll just have to see what direction it's heading in. What is its velocity relationship with the sun? Is it in orbit? Is it on its way out? I don't think it has enough fuel to do the kind of delta V that will put it into a heliocentric orbit, but time will tell exactly what they end up doing. So yeah, I don't know. It all depends on funding and its final velocity and trajectory. So let's see. There will be pictures from the New Horizon coming up. Yes. It takes a long time to download these pictures. We should get low-res images coming back tomorrow. And it is anticipated that the first high-res images in color we will have in hand in February. This is kind of, it's basically a 100 baud modem. So if you remember how long it took to load little tiny pictures on the internets or out of email back in the days of dial-up, this is like the earliest days of dial-up. Okay, let's see what else. So Ed Thomas is asking, if New Horizons could visit one more Kuiper Belt object, which one would you be interested in seeing? Well, so it can only visit things that are exactly within a specific cone of what they can change their velocity to reach. That I know of, they don't have the capacity to reach any of the big, cool dwarf objects that are out there. And so this means it's just going to be visiting whatever ice ball is most convenient, and I am in favor of convenient ice balls, so I won't be picky. The biggest of the convenient ice balls. Let's see. How much data is usually there to download? Yes, it has an 8 gigabyte max, so it takes time. No, not 1,000 baud, 100 baud. It's very slow. It can sometimes get up to 500 baud. It depends on what they're doing. Yeah, it was super slow. So do we have other questions out there? So other things that are currently going on. So life-taking biotech, it's so slow because the signal goes down, the signal strength goes down as the square of the distance. So if we have, let's call this the sun, and let's call this New Horizons. As New Horizons moves away from the sun, the Earth. I have a very dead Earth. My puppy tried to eat the planet Earth. So let's go with the semi-dead planet Earth. Okay, so here's the planet Earth. As New Horizons moves away, the distance continues to increase. When it is 3 times further away, the signal is reduced by a factor of 9. So the signal is 9 times weaker. When it's 4 times further away, the signal goes down by a power of 16. This square is because the signal coming off the spacecraft is expanding out over time, and it's essentially covering a larger and larger area. And we're constantly intercepting with our dishes the exact same area of the sky. So the signal goes down and down and down. When the signal goes down, the way you compensate is you basically scream each bit across the solar system. So basically New Horizons, instead of being out there going 103149, whatever it is in hexadecimal or whatever set of ways that it's sending the information back, it is instead going, hey Earth, 1, 3, and because it is slowly shouting each bit, we're able to intercept them here on Earth and understand exactly what it's saying. I hope that made sense. Hanny is asking, is it possible to communicate with lasers? Yes, but lasers still spread out over distance the exact same way. Yeah, so a laser beam that you shoot from here on the Earth at the moon is going to be kilometers across by the time it gets to the moon. How large is New Horizons? It's about the size of a large SUV. I think maybe the size of a small SUV. It's a fairly small spacecraft. No, it doesn't have a fusion reactor. So it has what's called a radiothermal generator. This means that it has a energy pack in it that has nuclear fuel, and as that nuclear fuel decays, it generates heat. That heat powers the generator, and my dog is trying to unplug my computer. And so while we can say it's nuclear powered, it's not nuclear powered in the sense that like the energy is being generated by anything more exciting than just normal radioactive decay processes. Yeah, and I do not know why Automod decided that radioactive decay was not something we could discuss. Oh, isotope. Why would the word isotope be banned? That's weird. So signals do travel all the way across space. The issue is, are the signals coming from us to other civilizations or from other civilizations towards us louder than the background radio noise? Our own planet's radio signals are all mixed together. Every radio station out there, every television station, anything giving off radio light is all a jumbled mash going out across space. And that signal has to somehow shine brighter than radio galaxies, than the radio emissions coming from happily feeding black holes, from young stars. There are so many sources of radio emission that is naturally occurring. Even our own planet Jupiter can be overheard in the radio, and If you follow some of the instructions on the internet, you can even convert an old DirecTV dish into a radio telescope and, well, give Jupiter a listen. With so much radio noise out there, our own planet just doesn't give off that much signal. And so we would be very hard to discern against everything else out there. And this is the problem that we face when we're looking for signals from other worlds. How do we see that the jumbled mash of all the radio stations transmitting at once is a coherent man-made signal? And how do we even detect it given how faint the signals would be? What we're actually hoping for is that someone will know we're here, that someone will see our planet orbiting our sun and beam a radio signal directly at us. That would be something that we do potentially have the capacity to detect. Hasn't happened so far, but that hasn't stopped people from looking. Let's see what other questions we have. Life Taking is asking, can signal boosters in between the satellite and Earth be used to keep the signal strength intact? I wouldn't say keep it intact. This is actually kind of what we do with Mars. We have a variety of robots on the surface of Mars, and those robots don't generally communicate straight back to the planet Earth. Instead, they're relaying their signals to a variety of different spacecraft orbiting above. These different spacecraft then capture the signals that are quite weak coming up from those rovers and landers, and then they get rebroadcast loud and clear straight back at the planet Earth. It is hoped that in the future we'll be able to use CubeSats to form this kind of a relay network. The Mars Co A and B were proofs of concept for this idea. When the InSight lander landed on Mars, Mars Co A and B sent us, thank you so much for the follow, Mars Co A and B sent us back the signals from InSight during the landing. Unfortunately, this technology is very, very new, so it's going to take potentially decades before we can get this kind of technology into the outer solar system. Let me see what else is out there. So Hanny is asking, could we make a big radio emitter from a lot of smaller ones? You can detect signals that way, but sending signals that way, you don't really gain anything. With sending signals, it doesn't depend how big your dish's area is. It strictly depends on the power. So whether or not you put the same signal out of 5 dishes that add up to however many watts of power, or out of a single dish, that power is the same power no matter how you send it. And it's a whole lot easier to get a clear signal out of a single dish. So yeah, you can detect things more sensitively that way because you're adding up the area, and the collecting area is able to intercept more and more of the signal. Let's see what else is out there. So once something is beyond the event horizon, that we can't get the signal back. Not the event horizon, essentially the visible horizon of the universe. We can't get that signal back. It's a light travel time issue. So even if we put relays in, those relays won't be able to help us out because they're going to be suffering the same issues. The light travel time just isn't there. So Bad Panda is saying that he read somewhere that New Horizons use 2 transmitters broadcasting with different polarization to increase bandwidth. I'm not sure if increasing bandwidth is the right way to put this, or increasing the number of pipelines. If you have things on 2 different polarizations, you can be sending different information on both and then capturing them here on Earth. I need to read more about how that works. So Silvershot 3, faster than light travel through normal space can't happen by the laws of physics. the question starts to become, can the kinds of technologies that exist in science fiction, the gates of the old Battlestar Galactica series and of Babylon 5, the traveling through subspace of the Star Trek universe and Star Wars, can we find these ways to escape normal space and thus get from point A to point B without going through all the points in between? That is what we have to figure out how to do if we want to get from places faster than conventional travel through space would allow, because conventional space limits us to the speed of light. New physics would need to be worked up. So Trillion is asking, can we only communicate back to New Horizons and 100 baud, or are the transmitters on this end more powerful? The transmitters on this end are more powerful. We still have the ever so frustrating issue that it takes 6 hours to get the signal all the way across the solar system. So it's still a slow process, but the reasons we can get more bytes there faster. Oh, so many things to be frustrated. So Hanny's Vorverb is asking, isn't Osiris Rex going to bring back something? Yes, it's going to find a rock, steal it off of the surface in a dive and grab and run, and then bring it back to Earth. I believe we are 1 year out from the grabbing part, but we're going to start getting the mosaics in the next few weeks that will be used to find the rock that is going to be nabbed. We actually are developing the software to do that right here at CosmoQuest. So, do we have any other questions out there? How about taking advantage of quantum tunneling? Alien Twitch TV is asking. So the problem with quantum tunneling is you need something that acts like a wave function, where the wave function is bigger than the object. An electron has a wave function that allows it to interfere with a slit to essentially interact with the world around it because its wave is bigger than it is. You and I, well, we have wavelengths too, but our wavelengths are way smaller than we are. So our wavelengths don't interfere with one another, and we can't use these same kinds of effects. This is why you and I don't act like waves. Hanny's Vorver, Bennu will not miss a rock. It is covered in rocks. So let's see, do we have any other questions out there? Yes, life-taking. We are all out of work today. As of midnight last night, we were no longer funded by NASA, and none of our contracts transferred so far. And so our only funding is through the donations that are right there. I'm going to be working to turn those donations into contracts for as many of my staff as I can. But where it normally takes 3 to 6 months to even get grants in front of somebody to review, and it typically takes a year before you can get grant money back in hand, it's going to be a time for tightening belts. I'm going to try and work a miracle. But right now, yeah, all your donations, that's what keeps us going. Yes, Veronica Cure, you will be able to help find that rock. We just need the images back first. So Trillion 20, or 20, Trillion H2O. The software, it's not that complicated. So Life-Taking is asking, can you talk a bit about the struggles of being a scientist in field of physics? I don't want to cry on air. On a day when I haven't just lost all income, maybe. Not today. I would love to bring home Rocky McRockface. I will propose that to the Osiris Rex team. Or at least mention it to my contacts on the team. That would be fun. Okay, other questions, hopefully ones that won't potentially make me cry on air. Will the stream keep going? Not all day today. I do need to go do other work. But yes, because you guys donate bits, donate dollars, make subs, Annie Wilson and I, starting today, we're going to be splitting in half the funding that comes in on this channel. And that's going to be how we keep this channel going. So while I haven't swapped out the goal below, I will be swapping it out so that you can see how much we're trying to make each month so that we can, well, afford to eat. It's a thing. It's a thing. Yeah, it's a good day for the blues, Larry. That's entirely true. And there's 42 viewers right now, and I currently find that very pleasing. 42 is the magic number. Thank you, Veronica Cure. Thank you so much for the bits. They all add up to us still having a future. So other things out there that you would like to know, I will try and answer everything I can. And when we run out of questions, I'm going to go back to working on making the CosmoQuest website all that much better. We've been in a situation for the past 2 years. Thank you so much for the subscription. And thank you, Stegan, for gifting all those subs. That's amazing. That makes all the difference in the world. And hey, Phoenix, it's good to know that you're out there. Hey, Michael, it's good to know that you're out there too. Thank you all for being here. Thank you, Astro YYZ. Yeah, Silvershot. I'm actually going to go to the DoD and see if I can get funding to do science from them. Never thought I'd be asking them for funding, but hey, I will ask anyone right now. Thank you, Ed Thompson. Thank you so much. So for the past 2 years, we've only been allowed to make updates to the to the CosmoQuest website if we went through a whole bunch of different approval processes. And we were often required to make changes to our site that we didn't like. And it turns out, after doing a bunch of research, you didn't like them either. And so as a result of the required changes we had to make, we lost a huge amount of our citizen science audience. Thank you so much for the sub. And we don't like that. So we are going back to our roots, but with the most modern of technology. And so as soon as we are done deploying all the changes, you are going to see a better interface. We are putting the colors back. We were actually required to remove all the colors from our mapping interface. You're going to see a whole lot of new and exciting stuff. We're doing this because we know it's the right thing to do. And because of those dollars that you donated, it will keep us going long enough to put our site back to being something we are truly proud of. We will be deploying things in the next few days. We have a brand new citizen science project coming. Thank you, YYZ. I think the stream is just catching up with stuff you did a few moments ago. We have a new citizen science project coming that will involve having you guys help us map out glaciers on other worlds. Not on other worlds, glaciers on other continents. And it should be awesome. And yeah, we're going to get it all done and get it launched as quickly as we can. Thank you guys so much for everything that you're doing. This means the world to me. We're trying hard out here. We're going to do everything we can to keep you guys going. So Life Taking is asking, can you tell me the goal of CosmoQuest? CosmoQuest is your place to both learn science and do science. Those of us that you see on our stream, we all have our personal streams. This is my job. I just am not currently getting paid for it. We since 2012 had been funded by NASA to create a variety of citizen science projects that would allow you to help mission scientists explore other worlds, map out features, find the safe places to land and the scientifically interesting places to explore. We were told, unfortunately, back in August that there is a chance that James Webb Space Telescope cost overruns and changes to the policies on how citizen science is funded might lead to our funding getting cut. And the reality is our funding got zeroed. We found this out at the same time that I was working on switching to a new and better institution. We are now hosted out of the Planetary Science Institution, which has over 100 PhD researchers working on a myriad of projects to explore our solar system. So at this time when we're set up better than ever before to accomplish our goals of getting your help exploring our universe, we had our funding plugged. Now, we could have decided to turn the site off, to tuck our tails between our legs and go away. But we're fighters, and we're trying to figure out how to keep the science going. And you are making that possible with your donations. Now, our programmers are arriving. It is going to be me, Tanner, Tim. See who else joins us today. We're working to revitalize our website, making things new and more beautiful and more interesting for you to engage in science. So I'm going to hang up this stream and go make some science. We will be back tomorrow to bring you another episode of The Daily Space, and I may have new website bits and pieces to show you. If you want to follow along, get involved, and perhaps volunteer to help behind the scenes, join us over on Discord. This is where we hang out, and we invite you to join us. Beyond that, as always, we are sustained by you. Every subscription, every bit, every donation really matters, and I can't tell you how grateful I am for all the help that you've given us. You've shown me that we are truly a community that takes care of one another. And in this world, that really matters, and I'm so proud to get to work with all of you. So I will be back tomorrow. I will be on Discord all day. I hope that you will join me, and together we can learn and explore our solar system. So thank you, and wherever you are, have a fabulous morning, evening, or afternoon. And remember, go outside and look up.